Okay. Then session 2, we will talk about um, how to calculate uh, some corresponding functions, or calculate the some values for the parametric curves about calculus. So later on, I will show you. So session 2, we will talk about something about calculus with parametric curves. So when we talk about calculus, in the beginning we just learn about the differentiation, right? And when we calculate differentiation or derivative, normally we just talk about its tangent, right? So if I give you the parametric curve, can we use it to calculate its tangents? And also, can you just try to get its area? So when we just want to calculate its tangent, when I, when we were giving y is equal to f of s, right? So we just focus on dy over dx, right? So in the past, in the previous semester, normally we will be giving y is equal to f. So if you want to get its tangent, you can calculate its slope first. So it will be dy over dx. But right now, if we just giving s is equal to f of t, then y is also g of t, what should we do? If we were just giving s is equal to f of t and y is equal to g of t, what should we do? So we still follow the same way, but we will do this way. Over dt. So from the differential aspect, you can see dt. If you still remember, you can regard dt as a variable, right? So we can just cancel it and go back to the origin. So right now we just try to let dy divided by dt. But for the denominator, dx will also be divided by dt. And you can see if we just hide dt here, we still can get back to the original dy over dx, right? So I just give you an example. If I give you s is equal to a cosine t, y is equal to b sine t, and also show you the range, the domain. The range for the domain is t from 0 to 2 pi. Can you just find the tangent to the curve at a over square root of 2 and b over square root of 2? So actually, you also can notice that if we will not follow this one, what should we do? One way is, solution one is, do you also think about that we can just follow the pathway we calculated? We can try to, you can see solution one is by this one. we know the relation, right? So can we just convert it as S over A is cosine t, Y over B is sine t. So with this, we can get S over A square plus Y over B square is 1. So what's the shape for this equation? It's a ellipse, 椭圆 is an ellipse, right? So based on this, we can conclude actually it is just a ellipse. S and Y, right? So this is trying to describe the ellipse, and the point, the question that requests us is here. So this point is A over square root of 2, B over square root of 2. Then we are trying to get the tangent. Tangent should be here. So in the past, if I give you this one and also give you the passing point is this one, how can we get the tangent line? How can we get it? Using implicit differentiation. Did you remember? 我们用那个对，以函数为分，对不对？ We can just use implicit differentiation to get the slope. And using slope and the point slope equation, you can get this tangent line, right? So this is what we learned last semester. But this semester, we should regard it as a parametric function, parametric curve. So we will have the solution too. Is we still need to focus on its m, its slope, right? So m should be dy over dt when t is equal to 1/4 pi. So we can continue to do that by dy over dx. Dx. Here should be dx. Then divided by dt. And still t is equal to 1/4 pi. So based on this, because y is b sine t, so when we differentiate it with respect to t, we can get b cosine t. Then over a negative a sine t, t is equal to 1/4 pi, right? So in solution one, we just use implicit differentiation. So in solution one, we use implicit differentiation to get it. But for solution two, we try to get the slope by using these two parametric equations. So based on this, we can get the slope is negative b over a. So you can use the point plus this is the point, this is the slope, and by using point slope equation, we can get the tangent. I will skip this part because it's not that hard. But the solution is different. This one is used implicit differentiation. This one is used just try to follow its original parametric equations. Then we can get the slope by this one. So this one is very important. Then with this, we can continue to calculate. A higher degree differentiation, derivative. So if we want to calculate this one, so here you can see this is a first order derivative, right? This is a first order, but this is a second order. So maybe you will think, oh, okay, just follow this one. Can we just do the same thing for, okay, here we can do it by this one. Actually, it's wrong. You cannot do it by this one. This is D, okay? You cannot do it by this one. The correct one should be, this is correct one. It should be, try to calculate y prime first. Y prime should be dy over dt over ds over dt. Then the second step is when we want to calculate double the second order derivative, then it will based on the differentiating first order derivative. So it will become this one. So in this case, it will be d prime over dt, then ds over dt. So this is the correct one. Okay? So please do not follow this way. Please follow. Step 1, get the first order derivative first. Then continue to differentiate the result, then we can get the second order derivative. This is the correct one. So I will show you an example. For example, can you find the second order derivative for y as a function of t? In this case, if s is equal to t minus t squared, and y is equal to t minus t cubed to the power of 3. Okay, so if we want to get the second order, the solution here should be, first step, try to get the first order derivative. Then we can get, it will be dy over dt over ds over dt. So it's not that hard for you because you already know y is t minus t cubed. So the answer for the numerator will be 1 minus 3t squared. For the denominator, it will have 1 minus 2t. Okay, then if we want to continue to get the second order, then we need to differentiate y prime so that we can have dy prime over dt, ds over dt. So we should dt this blah blah blah, right? This is y prime. Y prime comes from this one. So we should do this for the numerator. Then over 1 over 2t. So I also will skip this part, but I just want to emphasize you should have more patience to calculate this part and then find the equation result. So just follow these two steps. Please do not do this like this way. It's the wrong one. It's the wrong one. Okay. So I will give you. This is about how to calculate the tangents based on the parametric equation. And then I will show you how to calculate area by using one example. So here I will show you another example that please find the area enclosed by the asteroid. Asteroid in Chinese is 星形线. You know, when we just learn the parametric function, why we need to learn the parametric equation of parametric curve? Because you know that is not easy to just simply use S and Y to describe some spatial curve. For example, this is 星形线. I can show you first. The function is look like this one, cosine to the power of 3t, and y is sine to the power of 3t. Then t's range is from 0 to 2 pi. And eventually we can get the curve just like this one. We can see the shape really follows some rule, but follow this rule. But if you just want to simply use S and Y to describe the same curve, it is impossible. It is impossible. OK， 所以为什么我们要学参数式？等到我们学那个极坐标的时候呢，其实可能了解的更多。但是你会发现，在这里有很多这种奇形怪状的图形。好像这个，你绝对没办法用 SY 去表达出来。SY 可以表达什么？曲线是像抛物线啊，像圆形啊，像椭圆啊，这已经是它的极限了。那如果你要表示这种比较特殊的线，包含刚刚的摆线，有没有？其实你是没有办法简单的，刚刚讲的摆线，千万不是这个注意哦，它不是抛物线哦，这种你也没办法用 x 跟 y， 单纯用 s 等于y等于 blah 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 x， 或是 s 跟 y 把它 mix 在一起建构出来的。星形线也是，那你会发现这里面有很多奇形怪状的曲线事实上都是用参数式在表达，所以这个也是让大家了解到为什么我们要学参数式的原因Okay, so how can we just get this one? Actually, is also you can just use t is equal to 0. Then you can get this point 1, 0. Then you can also use t is equal to 1/2 pi. You can get this point 0, 1. Okay, so similar, you can just have some t in between 0 and 1/2 pi, and then you can get more points, and then finally you can get a shape. Just like I just plot the point first, then connect this point together, and then finally you can get a shape. So the question is, can we just find the whole area? Right? But if we just want to get the whole area, can we just focus on this part first? If we can get the green part first, then we can simply times 4. Then we can get its real size. Okay? So the question will be, simplify as a is equal to integral. You can see here is s is equal to 0, right? And this is s is equal to 1. So integral from s is equal to 0 to s equal to 1. Then for in the past we also learned that Riemann sum, right? We can just use the function y as a high times dx, right? Y times dx. Then we can get this part as this one. Then times 4. Maybe I just use yellow one. Times 4. Then we can get the whole area, right? So then we just focus on this part. We just focus on this part. So then how can we deal with this one? Then we can simply move 4 out of this expression. Then integral from, okay, then you can see y has been described as this one, right? So we can get y is sine 3 power 3t. Then what is dt? dx. What is dx? So as for the dx, we can use this one to try to get ds. So how can we do? Because s is equal to cosine cubed t, so that dx over dt is equal to 3 cosine square t times negative sine t. Right? Because s is cosine 3 power 3t, when we differentiate with respect to t, then we can get 3 cosine square t times differentiating cosine t, so we can get negative sine t. Then we just move dt to right hand side. So we can get dx is equal to negative 3 cosine t square t sine t dt. So we can just use this one to replace it as negative 3 sine t cosine square t, then dt. So you can notice that the integral will convert it as an expression in t only, right? Papa t times papa t, and also papa t then dt. So we need to convert s from 0 to 1 to t basis. So t here will be 0 to 1/2 pi. So we can have t from 0 to 1/2 pi. So all expression will be based on t. Okay? So why I just take the absolute value sign here? Because did you notice that when we calculate the integral, actually 0 to 1/2 pi and 1/2 pi to 0 are different. We need to add additional negative sign later. However, if we just take the extra value, we will just force the final result is a positive number. Okay, so to be safe, we just add the extra sign here. Okay, let's just continue. Then here we can just move the -3 out of the expression. So we can get, we just move this out of the expression, so we can get 12 integral 0 to 1/2 pi. Then since here we have sine to the power of 3, here we have another sine t. So in total we have 4, right? And for cosine t, we have 2. Cosine we have 2. So that will be cosine square t dt. Then the problem will be reduced to an integration about sine to the power of n times cosine to the power of n, right? If you still remember, in chapter 8, we also encountered the problem. At that time, I just asked you to check n is odd or even. N is odd or even. Both of them are even, so we can use the half angle formula to convert it. So it will be 12 from 0 to 1/2 pi. Then for this part, we can reduce its strength for its power. Then it will be 1 minus cosine 2t over 2 square. Then for this part, we also can use another half angle equation formula to convert it as cosine 2t over t, then dt. So we need to continue to do that. We need to continue to explain it. And then comes them together. So I remember we also did the same thing in chapter 8. So I will skip this part, and then you can just finally you can get the result is 3/8 pi. I know that is not that easy because the form will become very complicated. But anyway, I will skip this part because it's just about the calculation. I think you can do that by yourself. 所以这边呢，不要忘了，你会发现这边用到了什么？这边用到了上学期所学的面积哈，所以上学期学的不能都忘了哦，忘了要回去把它找回来哦。等一下我们还要讲旋转表面积的，那些都是上学期讲过的。在参数式的时候，它其实都可以再讲一次啊。我们只不过用几个例子来讲，但是这个呢是用来做面积的哈，所以千万要记得它这个呢，就是高度去乘以一点点的宽度累加出来的面积，这是第一个要记得的哦，要回想的，这是上学期的。第二个是这种积分呢，本来的式子你会发现它本来式子都是跟 x 跟 y 有关系的。但是它给你的是什么？参数式啊，怎么办？这种全部要把它的 x 也好 y 也好 dx 也好，全部用它给你的参数去换。首先呢，我们看到 y 就直接把它带进来，这没问题。可是 dx 要把它想办法变成 dt， 怎么转呢？就把这个 x 对 t 微分，去转出来这个 dt 的形式。所以你会发现，那这个被积分的这个式子全部变成 t 了，而且积分的角度是从 t 了。那不要忘了，本来这里是0到1的，你要转换成 t 的角度 ，t 的看法来看，所以这是从0到 2/派。哦，那最后呢，这些都是偶数吧？啊，这些都是正的嘛，所以这个积分式子就可以自动拿掉，因为这边都是横正的，这边是4次方一定是正，这个是2次方一定横正。哦，那第3个这个式子，这个题目很重点的地方，第3个是第8章刚学过的 m 次跟 n 次，如果 m 是偶数 ，n 也是偶数的话，记得要用那个半角公式，把它的强度呢从4次的变2次，2次的变1次。但是展开很大，有点大哈、哦，这展开出来，这边有3项嘛哈、哦，是2次式，这有2项，3乘以2会有6项，要整理一下。好，那整理过程这个我就跳过去哈、哦，这结果呢会是这个，哦，就是这个。Okay. So then I will move to another topic about arc length. But this time, we just focus on parametric curve. So the only difference is this time we just focus on parametrically defined curve. Actually, it's just about a parametric curve. So in the past, when we talk about length, actually we are talking about when I give you a curve, then I ask you to calculate from A to B. Can you find the whole length? Right? Can you find the whole length? At that time, what should we do? We just divide it into several parts. So here, maybe t is equal to tk minus 1. Then at this point, it will be t is equal to tk. Then, of course, we have t0, t1, t2, t3, blah, 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 to tk minus 1. Then tk plus 1, tk plus 2, blah, 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 right? So we just divide it into many small pieces. Then we just focus on this piece. Then we can focus on, if we can calculate this piece, then finally we just sum all of them together. Then we get the final result, right? That's just like Raymond sum, right? So we are talking about the LK here, right? LK here just defined as the link from tk minus 1 to tk. So here, suppose this should be pk minus 1, and then this point is pk, right? Then, of course, the true curve is this one, the white one. But we just use LK to approximate the true one. Okay, so in this case, we also given the parametric function as s is equal to f of t, y is equal to g of t. Then LK here, we will regard it as delta sk, here is delta yk. So LK here can be regarded as square root of delta sk square plus delta yk square. So L, if we want to know the total length, almost equal to sigma. K is from 1 to n LK, right? And then also we can just express it as k from 1 to n square root of delta sk square plus delta yk square. Then we will have another inference. How can we just convert delta sk, delta yk into the same parameter? We just focus on here. The lk here can be expressed as delta sk square plus delta yk square. Then it will be regarded as square root of f of tk minus f of tk minus 1 square plus g of tk minus g of tk minus 1 square. Right? Do you agree with that? Because t is equal to tk minus 1 implies that the point here should be f of tk minus 1 comma g of tk minus 1, right? For this point, it will be f of tk comma g of tk, right? Because we just use parametric curve. So of course we need to focus on these two parametric equations. So we just use this one, this difference square plus this difference square. Okay, then I hope you still remember we can use the mean value theorem. That means we can find tk star and tk star star between tk minus 1 and the tk, so that f of tk minus f of tk minus 1 over delta tk is equal to f prime of tk star. Then we also have g of tk minus g of tk minus 1 over delta sk tk. Delta tk is equal to g prime of tk star star. So why I say tk star and tk star star? Why I did not use tk star and tk star? Because they just apply the mean value theorem twice. One is for f, one is for g. So that means tk star is not necessarily equal to tk star star. 我们用了2次的均值定理，这2个均值定理用到一个是 f 函数，一个是 g 函数，所以你在找这个均值，就是中间比均值定理的时候呢，事实上这个 tk star 不必然跟 tk star star 是一样的，因为一个是 f 函数，一个是 g 函数，对不对？还记不记得什么是 mean value theorem？ mean value theorem 就是说 ，maybe I just show here， 就是如果我给你函数 f， 对不对？然后呢，这边有一个 tk star 1 tk minus 1， 这是 tk 对不对？这是 t 了哈。So we can just link them together. We definitely can find some tk star here. Its slope will be same as this one. Did you remember? Right? The slope should be the same as this one. If you just you have forgotten, please go back to the chapter 3, as I remember. Okay, so with this one, we can just move this to here. We can move this here to here, so that the whole equation, the whole expression can be changed as square root of f prime tk star square plus g prime tk star star square. Then outside the square root, we still have delta tk. Because we have delta tk here, we also have delta tk here, so we have common term for delta tk. Then we just, after taking the square root, we can just move delta tk out of the square root. Okay, so after we have this, then the whole expression will become square roots sigma square root of f prime tk star square plus g prime tk star star square. So finally, with this support, L can be integral AB square root of f prime t square plus g prime t square dt. So as non p is approaching 0 or n is approaching infinity, then finally we can have the result. So if you cannot memorize it, at least you need to memorize this formula. So from A to B, square root of f prime t square plus gt prime. So you can just simply see, when we just divided it into many subpieces, then for each piece, if our partition, the norm for the partition is approaching 0, or we can say we have infinite number of pieces, then we can go to, for each point, we can regard it as a small piece. Then finally we can get this result. 记不记得这也是上学期的延伸，对不对？上学期这部分很相似，应该有推导过给大家看，就是如果你的黎曼河你切得很细，对不对？切了 n 块，这是我故意画很粗给大家看的。但是随着这个 n 变成无穷大，或者你的切法那个弄 p 趋近于0，还记不记得弄 p 是什么？你的 partition 最大块的那个，如果连最大块的都趋近于0，代表什么？你的切割是无穷段的切割。那这时候呢，每一个点呢就变成一个 piece。那最终呢，每一个点都是个 piece， 每一个 t 都是一个 piece， 最后把它加总起来。So let's just stop here. But next Monday, I will show you some example by using this formula. Okay? So let's just call it a day.